everyone. Good afternoon. Right. Right. People who are in the live, just tell me. Now, live එකේ ඉන්නයි මට කියන්න. Can you hear me properly? I need responses from everyone. Can you hear me properly? Come on, lamai. Right. Fine. Now, today is our 4th day. Am I correct? හතරෙන් දවසේ නේද? හරි. එතකොට මේ අපි for the last 3 days actually we completed the first chapter, first I would say lesson or unit of the unit 1 atomic structure, right? First chapter of atomic structure, right? So it's like this, Buddha. We are following a 3-month plan. I would say 3-month plan, right? 3-month plan from March to May. I would say for the first lesson, since I'm running with little bit of slow speed, I would say 4-month plan from March to June. මම මෙහෙම කියන්නම්. හරි? right. මාර්ච් ඉඳන් ජූන් වෙනකන් අපි ඉන්නේ මේ 4-month plan එකක. නැත්නම් 4-month project එක තමයි ඉන්නේ. That's what we are doing actually, right? Right. Under which we are covering first unit of the syllabus. So unit 1 atomic structure. Unit 1 atomic structure will be covered, right? මේක තමයි අපේ project එක. Right, atomic structure, since this is a 4-month lengthy kind of a lesson which summarizes most of the O-level parts and most of the new concepts, right? So this will be divided into 12 chapters for ease of study, right? 3, 4, 5, 6, 9, 10, 11, 12, right? So the first chapter been done up until now. එමුණේද අපි පළවෙනි chapter එකේ වැඩ ටික ඉවර කරලා ඉන්නේ. එතකොට මාස 4ක් යනවා. chapters 12කට කඩලා first lesson එක උගන්වනවා. හරි? එතකොට මේ අපි පළවෙනි chapter එකේ වැඩ ටික ඉවර කරලා ඉන්නේ. For the newcomers and all, I'm telling you what we've done, right? එතකොට මේ අපි materials තුනක් පාවිච්චි කරනවා. We are following 3 materials. Tute, workbook, which comprise of, I would say, term test questions and all, and the third material is past paper book, past paper questions. So when you get the stuff, so this tute pack will be used up until June. July තමයි ඊළඟ tute pack එක හම්බෙන්නේ. ඒතර මේ මාස 4 අපි වැඩ කරන්නේ මේ tute pack එකේ. So you have your workbook, you have your tute, and you have your past paper question book. Right. So we need 15 class days, right? I mean we are very scheduled, lamai. That's why I'm telling you all this stuff. I can confidently say this stuff. We have 15 class days distributed among these 4 months to cover up the first lesson, right, which has 12 chapters, right? We have 15 class days in these 4 months. So we've completed 3 class days, right, to finish up with the first chapter. The history of atomic structure part is done, right? While finishing this first chapter, what we did was we completed the first chapter of the tute, we completed the first chapter of the workbook, and we completed the first chapter of this past paper book as well, right? Right. Today we are commencing the second chapter, which is nuclear chemistry. Nuclear chemistry කියලා තමයි second chapter එක තියෙන්නේ. තර nuclear chemistry කියන second chapter එකේ වැඩ ටික අපි අද පටන් ගන්නවා, right? මෙන්න මේ nuclear chemistry part එක second chapter එක class days දෙකක් මම කරනවා. I'll be consuming 2 of your class days. Means today and next Friday. Next Friday means 3rd of April, if I am not mistaken. So adai next Friday මේ දවස් දෙකේ මේ second chapter එක අපි ඉවර කරනවා. second chapter එක ඉවර කරනවා කියලා කියන්නේ ඒකේ theory ටික ඔක්කොම ඉවර කරලා, يعني tute එකේ ඔක්කොම second chapter එකේ වැඩ ටික ඉවර කරලා workbook එකේ වැඩ ටිකයි past paper questions වල වැඩ ටිකයි ඔක්කොම කරනවා. Right? So that's what I'm planning. That's my plan for these 2 weeks, right? Understood what I'm saying? So likewise, I'll be giving you plans for everything. I mean, when I commence my second lesson from July onwards, I'll be telling you what is the time span I'm referring, how many class days will be consumed to cover the lessons, how many chapters will be there, and what is my plan, right? So this is it. What is our major plan? What I promised for you guys? I'll be taking how many months? 25 months, right? I'll be taking 25 months. 25 months means we started our program on the beginning of the March, right? So I'll be working with you guys till 31st of March 2028, right? Till 31st of March 2028. By then, I'll be finishing off your syllabus, which is 14 lesson syllabus. So I'll be covering all 14 units within these 25 months in this manner. I'll be doing all past paper questions, I'll be doing all these workbook questions and everything, right? So that is my plan. So we are the first lesson, we take 4 months for it. So that's what, right? Anyway, for newcomers, හරිද අලුතෙන් ආපු ළමයින්ට පුතා ඔයාලට කලින් class days තුනම බලන්න පුළුවන්. හරි, you can watch all these class days and get the tunes and watch all these class days. For whatever the inquiries, I gave you our number. Keep this number saved. Note 777 50 මෙන්න මේ number එක save කරලා තියාගන්න. You can ask anything. තොර April, May, June කියන මාස තුනේ tutes නැහැ. You don't have tutes or tutes pack or whatever to next 3 months. අය ජුලයි මුල ওই විදිහටම box file එකක් එක්ක second lesson එකේ tute pack එක වාට හම්බෙනවා. හරි, up until then you don't have any tutes. So අපි වැඩ ටික කරගෙන යන්නයි තියෙන්නේ. This is our fixed time. Classes will be held on every Friday 2:30 to 5:30. If you start your schools and you take little bit this to be dragged down little bit, it can be readjusted into 3 to 6, but for the moment we'll keep it 2:30 to 5:30, right? Right, that's it. So I won't be recalling these first chapter parts, no, right? What I would do is I'll be directly starting with the second chapter, right? You take page number 7 of your tute. Move on to page number 7, nuclear chemistry. So that's what we are referring, nuclear chemistry. Right, listen to me, Buddha. We have 4 subtopics to be covered. Subtopics kiyak තියෙනවද cover කරන්න? I need answers, please. Subtopics kiyak තියෙනවද කියලා cover කරන්න? 4 subtopics to be covered. අපිට subtopics 4ක් තියෙනවා cover කරන්න. After completing this chapter, you must be capable of explaining nuclides, right? This is first part. And we are studying about nuclear reactions. Nuclear reactions. Radioactivity. And මම අද දවසේ කරන්නේ මේ ටික. This is for today. මම කියන්නේ I'll consume 2 class days කියලා. ඒතර next week එකේ මම කරනවා isotopes. Right. If I'm not mistaken, as far as I think, this is the only familiar word for you, right? You would have learned about these isotopes during your O-level curriculum. Am I correct? O-level කාලේ ඉගෙන ගත්තා නේද isotopes කියන ටික. But you haven't come across with nuclides, nuclear reactions, radioactivity, whatever. You didn't learn. එහෙම නේද? ඉගෙන ගත්තේ නැහැ නේ O-level කාලේ එහෙම දේවල් ටික. Right. ඒතර අලුත් lessons තුනක් තියෙන අලුත් topics තුනක්. Right. We'll study. Right. Under chapter 2, subtopic simple A, I need your what do you call these rough sheets and stuff for extra examples and all. Keep these things aligned with you. Right, subtopic simple A, nuclides. So we are going to study about nuclides now. Listen to me carefully, Buddha. Right, a nuclide means a chemical species, maybe an atom, maybe a cation, maybe an anion or whatever. We don't worry about its charge or nature or whatever. Forget about that. A chemical species, all are collectively be said as chemical species. Chemical species එකක් කියලා. Nuclide means a chemical species which nuclear composition is known. You know the nucleus actually is made out of what and what? Protons and tau cloud. Come on, Lamai, you know these words. Nucleus is made out of protons and neutrons. So we know the composition of the nucleus. We know how many protons are available within it, and we know how many neutrons are available within it. You understand what I'm saying? We know the composition of nucleus. If there is any species where we know the composition of it, අපි කවුරු හරි ස්පීෂීස් එකක composition එක දන්නවනම් nucleus එකේ composition එක දන්නවනම් maybe it may be an ion, it may be an atom, we don't care. That kind of species is said to be a nuclide. Nucleus එකේ composition එක දන්න species එකකට අපි කියනවා nuclide එකක් කියලා. Right? So let's say the chemical symbol of that species is X. එයාගේ chemical symbol එක nucleus එකේ තියෙන protons ගානෙන් carbon ද nitrogen ද oxygen ද කියලා අපිට කියන්න පුළුවන්. We can say like that නේ. So let's say the chemical symbol is X, right? So we put number of protons which is said to be proton number, or else you would have heard of it to be atomic number in O levels, and we put nuclide number. Nuclide number means the total of protons and neutrons, the summation of protons and neutrons. In other terms, you say this to be mass number. Am I correct? හරි. එතකොට මෙන්න මේ දෙකෙන් තමයි අපි නියුක්ලියර් කොම්පොසිෂන් එක ඉගෙන ගන්නෙ. එතකොට මේ දෙක දන්න ස්පීෂීස් එකකට අපි කියනවා නියුක්ලයිඩ් එකක් කියලා. Right? So the proton number would be denoted left bottom corner of the symbol. This is proton number. Very relaxedly learn. Henna relaxedly ඉගෙන ගන්න පුතා chemistry. I don't push you hard. This is nuclide number. You know nuclides are protons and neutrons. Protons and neutrons collectively said to be nuclides. So this is nuclide number. Or else this could have been said mass number as well. Mass number කියලාත් මේකට ඕනනම් කියන්න පුළුවන්. Nuclide number at the left top corner of the symbol. Right? So this is how a nuclide is represented. This is not the nuclide number, nucleon number. Rather, it has to be said in that way. Nucleon number. Nucleon number. I'll move with the note. My note එකත් එක්ක ඉස්සරහට යන්නම්. Nuclides are atomic species with specific proton number and nucleon number. The atomic number is represented in the bottom left side of the element's symbol, while nucleon number is represented in the upper left side of the symbol. So you may consume 2 or 3 rules or 3 or 4 rules of your blank space, and you may put this one in there. Make it done. How we denote a nuclide. So this is how we denote it, okay? This is how we represent a nuclide. right. අපි paragraph එකක් ලියමු යටින්. Right. තමයි keep this thing noted. A scientist called Koman came up with the definition of nuclide, right? Koman. I don't remember whether this is the 100% accurate spellings or not, but however it is pronounced to be Koman. Koman කියලා scientist කෙනෙක් තමයි මේ came up with the concept of nuclide. මේ nuclide කියන definition එක ගෙනල්ලා තියෙනවා. Right? According to Koman, there are 3 types of nuclides. How many types of nuclides according to Koman? 3 types of nuclides available commonly, right? So type 1 is naturally occurring stable nuclides. Right? Again පුතා මේ like nuclear composition එක තමයි nuclide එකක් කියලා අපි analyze කරන්නේ. ඔය දන්නවා මේ carbon, hydrogen, nitrogen වගේ elements such as carbon, nitrogen, hydrogen, they have very stable nuclear compositions. You know, carbon 612 is very stable. Carbon 612 means the nucleus with 6 protons and 6 neutrons. That composition is very stable. It is very commonly available. Stable kind of an composition. Am I correct? You know, oxygen 816 is very stable. So the nucleus with 8 protons and 8 neutrons is very stable. Those are said to be collectively as naturally occurring stable nuclides. Naturally occurring stable composition having nuclides, right? Naturally occurring stable nuclides. You know, elements such as uranium, radium, these are said to be which elements? Radioactive elements. හල් තියෙනව නේද විකිරණශීලී මුලතර radioactive elements කියලා කියන්නේ. They continuously release the radiation. Right? The reason for that is they have very unstable nucleus. Since the nucleus is unstable, they always try to release subatomic particles and radiations to make it stable. So those are said to be naturally occurring unstable nuclides. So the 2 main types are naturally occurring stable nuclides, naturally occurring unstable nuclides. There are certain very, very unstable proton and neutron combinations available within the nucleus, which make that nucleus is very unstable, highly radioactive, high energy releasing. But those are not naturally occurring, those are man-made ones. So those are said to be artificially generated, or else I would say artificially created unstable nuclides. Artificially created unstable nuclides. Understood what I am saying? So there are 3 types of nuclei I would say. Naturally occurring stable nuclides, where the proton and neutron combination is very stable so that it will not drive into radioactivity. Naturally occurring unstable nuclides, where the radioactivity occurs naturally. And artificially generated, or else man-made, right? Man-made unstable nuclides. You know, people, nuclear scientists, they've made that nuclear compositions where with the availability of that given number of protons and number of neutrons, the composition is very unstable. They releases high energy in becoming a kind of a stable nucleus. That energy humans, they consume for their nuclear weapons. That ultramax energy they use for their power generations in nuclear power plants. So those are called man-made or artificially created unstable nuclides. There are 3 types of nuclides like that. Understood what I'm saying? එහෙම වෛරක තුනක් තියෙනවා. Artificially create කරපු unstable nuclides, naturally occurring unstable nuclides, naturally occurring stable nuclides තමයි මේ වර්ග තුන. හරි? Right. You may write down what I'm saying. Write down under a paragraph. A nuclear scientist called Koman. Normal paragraph එක ලියන්න ඇති. A nuclear scientist called Koman. A nuclear scientist called Koman came up with the concept of nuclides. Came up with the concept of nuclides. According to him, nuclides can be classified into three main types. Nuclides can be classified into three main types. Can be classified into three main types. As in, you may use your red pen and write. Naturally occurring stable nuclides. Naturally occurring stable nuclides. Naturally occurring stable nuclides. Comma. Naturally occurring unstable nuclides. Naturally occurring unstable nuclides. And artificially generated unstable nuclides. Artificially generated unstable nuclides. As we can see, you may continue with normal writing. Nil panning blue pen again. As we can see, this nuclide classification comes. As we can see, this nuclide classification comes. This nuclide classification comes based on the stability of the nucleus which depends upon number of available protons and neutrons. Full stop. P and N කියලා දාන්න. Number of available protons and neutrons, which depends upon number of available protons and neutrons, right? Which depend upon number of protons and neutrons. Full stop. Right. So you are supposed to do a little example. Everybody example එකක් කරමු. මේ අර වගේ වැඩිපුර තියෙන කොළ බණ්ඩල මම කිව්වේ කොළ බණ්ඩල එකක් ක්ලිප් කරලා තියාගන්න කියලා. You may take it out now. Right. Write down chapter 2 nuclear chemistry. Right. Chapter 2 nuclear chemistry. Extra exercises වලට extra notes වලට වෙනම කොළ ටිකක් තියෙන්න ඕන ටියුට් එක ඇතුලේ. Right. Chapter 2 nuclear chemistry, under which subtopic simple A, nuclides. Under which subtopic simple A, nuclides. Come on, Lamai, quickly do. We don't have enough time. We have to go through, right? No point of spending time like nothing. Right, subtopic simple A, nuclides. Right, under which you may write example 1. Example 1. Right. පුතා ටියුට් එකේ තියෙන ප්‍රශ්නේ පොඩ්ඩක් වෙනස් කරගන්න. You may refer your tute. determine the neutron, proton and electron කියන එක කපන්න. You may cut the word electron. You only need to determine number of protons and number of neutrons. Determine number of neutrons, protons of given nuclides. So you are given 9 nuclides. You have to come up with number of protons and number of neutrons available within each of these. Hari කරන්න බලන්න පුතා. You may do whatever the things supposed to be done. Potassium 1939. Many nuclides වල number of protons and number of neutrons must be determined. Aluminium 1327. Barium 56137. Radium 88226. Right? Carbon 612, carbon 614, hydrogen 11, hydrogen 12, hydrogen 13. You are supposed to determine number of neutrons and number of protons available within each species. Guys, you are in the live, you can write your answers, right? You can anyway directly communicate with me. I want you guys very actively involved with the process. And active involvement is expected. I'll give you one more minute, right? Finish off. Right. Lamai, I need your answers. Right. Potassium 1939. Okay. Number of protons must be equivalent to atomic number or else proton number. It's 19. How do we determine number of neutrons available within this? Since this is the total of number of protons and neutrons, this is number of protons, what do we have to simply do? We can deduct 19 by this 39, then we are getting number of neutrons available within the nucleus of this species. Am I correct? Right. So what is the answer? Number of neutrons must be 39 minus 19 means 20. Check your answers. Harivara dagan. Number of protons must be 13. Number of neutrons must be 27 minus 13 means 14. Barium, number of protons must be 56. Number of neutrons must be, then comes the issue of simplification, 137 minus 56. Am I correct? So what was the answer? Is it 81? 81. Number of protons must be 88. 226 minus 88 means it's 138 if I am not mistaken. Am I correct? Yes. Carbon 612, protons high, neutrons high. Carbon 614, number of protons must be 6, number of neutrons must be 14 minus 6, 8. Hydrogen 11, which is called protium isotope, number of protons must be 1, number of neutrons must be 1 less 1 means what? 0. See, there are certain nuclides where number of neutrons available within it must be what? 0. The neutrons gana 0 in a nuclides thiyeno. But can we come across any of the nuclides with 0 protons? Proton එකක් නැතුව nucleus එකක් හැදෙනවද? නැහැ. But neutrons නැතුව මේ isotope එකේ nucleus එක තියෙනවා. හරි? Keep that thing noted. Here number of protons must be 1, number of neutrons also must be 1. In the case of hydrogen 1 3, number of protons must be 1, number of neutrons must be 3 minus 1 means 2. හරි. එතකොට මේකේ එක point එකක් අපි ලියමු, right? තරුවක් දාලා red pen එකෙන් ලියන්න යටින් මේ example එකට යටින් you may put a special point and write. According to above examples, we can observe the fact that according to above examples, we can observe the fact that according to above examples, we can observe the fact that අපිට observe කරන්න පුළුවන්. We can observe the fact that there are certain elements, so certain nuclides, I would say, there are certain nuclides with absence of neutrons, even though with absence of neutrons, even though there are no any nuclides available with the absence of protons. Even though there are no any nuclides with the absence of protons. Even though there are no any nuclides with the absence of protons. Even though there are no any nuclides with the absence of protons. Protons නැති nuclides අපිට කවදාවත් දකින්න හම්බෙන්නේ නැහැ. But neutrons නැති ඒවා තියෙනවා. Maybe that will be tested in your MCQ paper. Right. Subtopic Roman number 1 under nuclides, we have to follow two subtopics. The first one, Roman number 1, nuclear stability. Right. Listen to me very, very carefully, Buddha. These are very novel, new kind of concepts for you guys. Right, now we know nuclide means a species where the nuclear composition is known. Right. there are three types of nuclides: naturally occurring unstable ones, naturally occurring stable ones, artificially generated unstable ones. Right? Before that, since we are talking about these nuclear chemistry, nuclear bombs and nuclear stuff, I'm referring to the ongoing dispute between US and Iran. Hari. As science students, you tell me what has happened actually, what was the initial factor which started this war? මොකද්ද මේ war එක පටන් ගන්න ඕනේ වුණේ initial එක වුණේ? How did they initiate this? It was the nuclear program of Iran. Am I correct? It was nuclear program of Iran, right? So US blamed on Iran, having said they are making nuclear weapons. It will be a real threat for the whole world, so that we have to destroy them and blah blah blah. That's what they started, right? Right. That in nuclear program of Iran was uranium enrichment program. It is said to be uranium enrichment. Uranium enrichment. This was the nuclear program of Iran. Right. What they did was, you know, uranium is a radioactive kind of element. Uranium is anyway unstable element. The nuclear composition is unstable. However, naturally occurring uranium contains uranium 235 isotope heavily, 238 isotope heavily, right? If you get a naturally occurring uranium sample, uranium 238 isotope is more abundant, which is mostly available. I would say 60 to 80% or else 60 to 90% of the sample would be occupied by uranium 238 isotope. Its atomic number is 92, mass number is 238. Right? What Iranians was doing, they actually use very high centrifugal forces to rotate. Right? They use very high centrifugal forces and very high rotational velocities, right, to reduce number of neutrons available within this nuclei, and they converted most of these uranium 238 isotopes into uranium 235 isotope. මේ 238 isotope එක convert කරා 235 isotope වලට. They converted using centrifugal forces and centrifugation and stuff like that. Right? So with the neutron and proton composition of this isotope is believed to be highly unstable. Right? So what they did was, let's say initially the availability of uranium 235 isotope is, I would say, the relative abundance that is said to be in technicality. The initial relative abundance of this uranium 235 isotope was about 1% like. But with their enhancement or the enrichment program, they converted the availability of this uranium 235 isotope to 80% like. Right? So if there is a uranium sample where 235 isotope is available more than 90% like, it is considered to be a nuclear weapon, since it contains more than 90% of very unstable nuclei. Understood what I'm saying? So if we can initiate a blast or kind of a thing, a fire or whatever, it will be blasted and very high energy will be releases. That energy could damage more than 5,000, 10,000 square kilometers like. So it's literally everything. Right? They will create very high energies as in the form of thermal energy. They will emit very high frequency waves where it can cause changes in our DNAs as well. So the damage cannot be forecasted. It's that huge. So මෙන්න මේ විදිහේ uranium isotopes හදපු එක තමයි, this is called uranium enrichment. This is what Iranians were doing, right? So then how the war and the conflict and everything began. Understood what I'm saying? So these concepts are being used worldwide. And that's the story. Right. Moving into our lesson. Hari අපි දැන් අපේ lesson එකට આવොත් එහෙම, it's like this පුතා. We know what is nuclide, Nuclide means a nucleus with known composition. Nuclides වර්ගවලට බෙදෙනවා based on the nuclear stability. Naturally occurring stable nuclides, naturally occurring unstable nuclides, artificially generated unstable nuclides. Right. You know, everything has come with what? The nuclear stability. Now we have to study about how a nucleus of an atom been stabilized. Atom එකක nucleus එක කොහොමද stable වෙන්නේ, that we have to study. So it is this kind of story, Buddha. It's like this, right? Atom එකක nucleus එකක් අපි ගත්තොත් එහෙම, it's a very tiny region. එන්න පොඩි. හරිද? මේකේ similarly charged, positively charged protons තියෙනකොට මේගොල්ලෝ protons උයි neutrons උයි මේ nucleus එකක් ඇතුලේ තියෙන්නේ. ඒතර මේ protons වල මේ since they are similarly charged, they have potential to exert repulsive forces. Am I correct? Repulsive forces හැදෙන්න පුළුවන් මේ nucleus එකේ තියෙන protons වල. මෙන්න මේ repulsions හැදිලා nuclei destroy වෙලා යන්න නැතුව බේර ගන්න process එකට අපි කියනවා nuclear stabilization mechanism කියලා. මෙන්න මේ nuclear stabilization mechanism එක හොඳට වෙන nuclei are believed to be stable nuclei. මේ nuclear stabilization mechanism එක හරියට වෙන්නේ නැති nuclei are believed to be unstable nuclei. Unstable nuclei can be artificially created, as Iranians were doing, or else unstable nuclei are maybe naturally occurring, like uranium, thorium kind of radioactive elements. They naturally have these unstable nuclei. और මම කියන එක තේරෙනවනේ. ඒතර මෙන්න මේ nuclear stabilization process එක මේ හොඳට වෙන nucleus තමයි stable nucleus වෙන්නේ. හොඳට වෙන්නේ නැති ඒවා තමයි unstable nucleus වෙන්නේ. ඒතර මොකද්ද මේ nuclear stabilization process එක කියලා තමයි අපි කතා කරන්න යන්නේ. Right. පුතා, except to these neutrons and protons, another subatomic particles or else another nuclide is available within the nucleus. It is said to be meson. How do we call it? We call it to be what? A meson. There are mesons available within the nucleus of an atom. Mesons are charge carriers. They carries charge from one to another. කෙනෙක්ගෙන් තව කෙනෙක්ට charge එක අරගෙන යන එක තමයි මෙයාලගේ මේ function එක. They don't have charge. They are charge carriers. Am I correct? Right. So what they do is they carry positive charge from protons available within the nucleus to neutrons. What happens when proton release its positive charge to a neutron? Then the charge of proton neutralize. Everything charge එක නැති වෙනවනේ. It becomes what then? It becomes a neutron. Proton එක තියෙන charge එක නැති වෙනවා. මෙයා charge එකක් නැති particle එකක් වෙනවනේ. Nucleus එකක් ඇතුලේ තියෙන charge එකක් නැති particle එකක් කියන්නේ neutron එකක්නේ. It becomes a neutron. When neutrally charged neutron accepts the positive charge of this proton via this broker called meson, it becomes, while accepting this, it becomes a what? It becomes a proton. ඒක proton එකක් වෙනවා දැන්. ඔයාලට තේරෙනවද මම කියන්නේ? It becomes a proton. In the second split second, ඊළඟ split second එකේ, these are very continuous and very fast processes. ඊළඟ split second එකේ අර meson එකට මොකක් හරි වැඩක් තියෙන්නත් එපෙයි. ඌ මොකද කරන්නේ පුතා? ඌ මේ අලුත් proton එකෙන් අලුත් neutron එකට charge එක carry කරනවා. Then once positive charge is received, this again becomes a what? Proton, and this again becomes a what? Neutron. You got what I said? Since this process is continuously happening within the nucleus, a steady repulsive forces cannot be observed. Why? මේට අපරේ ප්‍රෝටෝන් එක ඊළඟ සෙකන්ඩ් එකේ මූ ප්‍රෝටෝන් එකක් එද්දි මූ නියුට්‍රන් වෙලා. ආය මූ ප්‍රෝටෝන් එකක් එද්දි මූ නියුට්‍රන් වෙලා. They changes. So stable, very stable and very steady repulsive forces cannot be formed. අපිට හැදෙන්නේ නැහැ. මේ දෙන්න අතර stable repulsion එකක් හැදෙන්නේ නැහැ. මේ දෙන්න අතරත් එහෙමයි. ඒකට stable repulsion forces හැදෙන්නේ නැති හින්දා, stable repulsions හැදෙන්නේ නැති හින්දා this nucleus, even though it's very small, very tiny, even though it contains number of protons within this very tiny area, since we can't predict stable, steady repulsion forces, this becomes stable. This won't be destroyed. But if we can, like Iranians, if we can rotate this or heat this or do whatever to change number of neutrons available within this process distracted. May process එක distract වුණාම then the nucleus becomes very unstable. Then what happen is, since the nucleus is very unstable, it release huge amount of energy and it broken. ඒක කැලි වලට කැඩෙනවා. Those are called nuclear fission reactions that release immense lot of energy that can be used as a nuclear bomb. That's how nuclear bombs and nuclear weapons are being created. So that's the concept of these nuclear bombs and all. So මේකට කියනවා nuclear stabilization process එක කියලා. මේ process එක හොඳට වෙන nucleus අපි කියනවා stable nucleus කියලා. මේ process එක හරියට වෙන්නේ නැති nucleus that we said to be unstable nucleus. Maybe natural, maybe man-made. Understood what I'm saying? So this is it. Right, Puda, scientists, they believe the effectiveness of this nuclear stabilization process, the effectiveness of this would rely on two factors. Factors දෙකක් උඩ rely වෙනවා කියලා. One, number of protons available within the nucleus. Two, the N upon P ratio of the nucleus. What ratio? I need loud answers, please. N upon P ratio. Number of neutrons divided by number of protons. That ratio and the number of protons. These are the two factors where they believe the effectiveness of this nuclear stabilization process depends on. Right? Right. I'll be dictating the note. Right? We will have to prepare a very nice note regarding this also. We know that the protons and neutrons are located in the nucleus of an atom. The stability of the nucleus containing protons and neutrons depend on two major factors, as you may highlight these words: ratio between neutron and proton. Ratio between neutron and the ratio between neutrons and protons කියලා දාන්න පුතා. The ratio between neutrons and protons. The ratio between neutrons and protons, comma, එක හදාගන්න, the typesetting error has to be corrected. The ratio between neutrons and protons, comma, number of protons of the nucleus. Nucleon number කියන එක කපන්න. Number of protons of the nucleus. Number of protons of the nucleus. Keep these things noted, Puda. The N upon P ratio value and the number of protons. So these are the two factors which evaluates the effectiveness of this nuclear stabilization process of a given nucleus. The reason for this is the nuclear stabilization mechanism in which charge carriers named mesons exchange the charge between neutrons and protons. Exchange the charge between neutrons and protons. Right. අපි මෙන්න මේ diagram එක පොඩියට අඳිමු. මට paragraph එකක් ලියන්න ඕනේ මේ mechanism එක. Maximum rule 4-5 ගන්න. 4-5 rules. That's all. Rule. Don't go beyond 5 rules. මෙන්න මේක අඳින්න. 5 plus කියන්නේ mesons, they carries positive charge. So NP, PN, that conversion can be expected. So you are getting a very well organized, a premium kind of note. So just compare this with whatever the notes available in your friends. So you may realize this is very comprehensive. This is very short. I don't write all the sheets here, right? So this will be very, very useful for you. Nucleus එකක් අඳින්න, neutrons become protons, protons become neutrons. 5 plus mesons will be denoted as in the form of 5. So they carries positive charge, 5 plus. Right. ලියන්න. Transferring of positive charge by means of mesons. Transferring of positive charge from protons to neutrons. Transferring of positive charge from protons to neutrons. Transferring of positive charge from protons to neutrons. From protons to neutrons by means of mesons. By means of mesons. By means of mesons. Continuously. Continuously is believed to be avoiding is believed to be avoiding the potential of having the avoiding of believed to be avoiding the potential of having stable and steady repulsive forces in between protons. Full stop. The stable and steady repulsive forces in between protons. The stable and steady repulsive forces in between protons. The stable and steady repulsive forces in between protons. Full stop. This overall phenomenon is known to be this overall phenomenon is known to be, you may use your red pen and write, nuclear stabilization process in chemistry. Nuclear stabilization process in chemistry. Nuclear stabilization process in chemistry. This overall phenomenon is known to be nuclear stabilization process in chemistry. Nuclear stabilization process in chemistry. තව එක වාක්‍යයක් ලියන්න පුළුවන්ද? පුළුවන්ද? right. පුළුවන් නම් ලියන්න. right. The effectiveness of this process within a given nucleus. The effectiveness of this process within a given nucleus will depend on the effectiveness of this process within a given nucleus will depend on the effectiveness of this process within a given nucleus will depend on number of protons and number of protons and will depend on number of protons and here n upon p ratio of its full stop n upon p ratio of its එයාගේ n upon p ratio of its full stop ඔන්න ඔය කියන දෙක අනුව තමයි it depends on right රඳා පවතින්නේ right you may move back to your rough sheets or whatever the books or whatever the extra kind of things you may write down subtopic Roman number 1 nuclear stability අර වගේ වැඩිපුර තියෙන කටුවැඩ කොළ ටික ගන්න Roman number 1 nuclear stability right අපි හැම වෙලේම ටියුට් එකත් එක්ක පැරලල් ඒ කොළ ටික යනවා හරි right example 1 determine number of neutrons and protons and electron not the electron sorry calculate the n upon p ratio regarding the atomic nucleus of each nuclides හරි මේ nuclides නවේ n upon p ratio figure එක calculate කරන්න කියලා කියනවා right පුතා I need you guys to do the simplification for 3 decimal places and round it off to 2 decimal places I need your answers which have been rounded off to 2 decimal places you know it's how we round off let's say we are getting 1.489 so what do we write since the third digit is more than 5 what do we do is we write it to be 1.49 am I correct how come we become it becomes 1.482 what do we do since the third digit is less than 5 we omit it and we write answer to be 1.48 that's called rounding off you know that stuff right the O level math did it right okay 9 sub examples are there 9 species are there I need you guys to come up with n upon p ratio figures of those මේගොල්ලන්ගේ n upon p ratios decimals දෙකකට calculate කරන්න බලන්න 10 minutes will be given විනාඩි 10ක් දෙනවා මම potassium 1939 aluminium 1327 barium 56137 radium 88226 carbon 612 carbon 614 hydrogen 11 hydrogen 12 hydrogen 13 okay you take your time you have enough time 10 minutes will be given to you I need you guys to come up with your answers properly take your time and do it Pudha Right. I need you guys to determine the N upon P ratio figure for each of these nuclei, right? Leisurely do it. You have enough time. You have 2 minutes, 2 to 3 minutes more. Come up with your answers, Lamai. Right. I need your support. I can't do the simplification. I need your support. I need loud answers of viewers, right? So the potassium 1939, the N upon P ratio is 20 upon 19. Am I correct, Lamai? So this is not the hard part of this, right? So I need your answer. 1.05. Am I correct? Is it 1.05 or 1.06? 05. Okay. Correct me if I'm wrong. Huh? Aluminium 1327, the N upon P ratio figure is 27 minus 13 means 14 divided by 13, 1.07 or 8? 6, 8, 1.08. Loud answers, please, Lamai. Barium 56 137, the N upon P ratio figure is 81 divided by 56. How did you end up? 1.4? 3 or what? Machang, talk louder please. Huh? Kenna? 1.442. Is it 1.42? ගන්න පුළුවන් මාකරකින්. හරි. Tell me what the answer? 45. 1.45. අන්න එහෙම කියන්නකෝ ළමයි නිකන් යාළු වෙන්න ඇහුවා වගේ නේ උත්තර දෙන්නේ. N upon P equals 138 divided by 88. What then? Huh? 1.57. This I know. The N upon P ratio is 6 divided by 6. Answer must be 1. Am I correct? Since we are keeping these answers for 2 decimal places, like when you get the answer 1, please keep it as 1.00. 2 decimal places must be represented there, right? That's why I am telling it 1.00. Carbon 614 N upon P ratio is 8 divided by 6, which is 1.33. Am I correct? Hydrogen 11 N upon P ratio is 0 divided by 1, 0. Hydrogen 12 1 divided by 1, it's 1. Hydrogen 13, the N upon P ratio figure is 2 divided by 1, which is 1. When you get answer 1, you keep it for 2 decimal places. 0, we don't need to put like that. Yeah, 2. That's it, right? Okay. Okay. Right. Subtopic Roman number 2 will move on. The belt of stability. The belt of stability. Right. Listen to me carefully. Lamai, it's like this, right? You are getting a huge opportunity from me. I mean, mama me Kurunegala class එකේ me English medium ළමයි දෙතුන් දෙනෙක් අලුතෙන් paper ලියන්න ඇවිල්ලා I went through their papers, right? So I don't conduct any English medium classes for 2026 batch නේ මේ සැරේ ලියන set එකක්. So they are believed to be the topmost students in most of the, I mean, when it comes to the English medium students who are sitting 2026 here in Kurunegala, right? They are believed to be the super genius kind of people. But you know, when they were supposed to write answers, they wrote answers for my papers last week. None of them were there in the top list. They were not there in the top 10, right? They are getting 90, 95, 98 kind of marks for their, what do you call, for their papers. Again, English medium classes වල කරන papers වල they are getting about 95, above 95 for sure. But මගේ papers ඒගොල්ලන්ට කරන්න දැම්මහම මගේ papers වල top list එක පටන් ගන්නේ සාමාන්‍යයෙන් 78 වලින් විතර 78 ඉඳන් 85 විතර වෙනකන් span එකක තමයි top list එකේ කට්ටිය හිටියේ ගිය සතියේ paper එකේ. None of them could reach at least 70% of the marks. ඒ ඔක්කොම තිබේ 60 ගණන් 50 ගණන්. හරිද? They were not there in the top 10. ඒ කියන්නේ බන්න කොච්චර ඒගොල්ලෝ mislead වෙනවද කියලා. Because English medium classes means they are very, very small samples, right? When it comes to the all island sample, Sinhala medium කරනවා bio 40000ක්. There are about 40,000 bio students. There are about 40,000 math students. Right? Out of which we have about 5,000 kind of students from English medium. Right? The English medium classes වල අර mainstream ගුරුවරුත් නෙමෙයිනේ ගොඩක් කරන්නේ. When they attend to English medium classes and become top players or get above 80 for each and subject, they think they are right at the top of the competition. But they actually not. They don't feel the competition. That isolation is there. But since you are following my course here, you know I'm one of the top guys there in the Sinhala medium process as well, right? So you are writing whatever the papers been created for the single medium guys. Let's say you are getting 80 marks for my papers in future exams and all, right? Let's say you are getting above 80, but it's like you are getting above 80 out of 2,000, 3,000 students. You understood what I'm saying? So you are right at the top of the competition of these all island competition as well. ඒ කියන්නේ ඔයාලා all island උත් උඩ ඉන්නවා කියන එක තමයි තේරුම අපේ ක්ලාස් වල උඩ ඉන්නවා කියන්නේ. මොකද for 26 batch 28 batch එකට ඔයාලට මම conduct කරන exams වලදී I don't need to separate Sinhala medium English medium. මම එහෙම separate කරන්නේ නැහැ. මගේ classes වල Ziyon එකේ කරන classes all island classes ඔය විදිහට මගේ classes වල top list මම දෙගොල්ලම combine කරලා තමයි හදන්නේ. ඒතර ඔයාලට position එකක් එන්නේ අර ළමයි 2-3000කින් එන position එකක් එන්නේ. හරි. So you can feel the main competition, mainstream competition. අර English medium class එකක් විදිහට isolate වෙන එක වෙන්නේ නැහැ. හරි. ඒතර මේ ඔක්කොම benefits ගන්න because you are following the same tube set, you are following the same note. I don't write anything in my note. මේ මම physically ඉන්න ළමයින්ට පේනවා මම මුකුත් note ලියාගෙන ඉන්නේ නැහැ ඔය හිස්තැන් වල ලියනවා. මම මේ දැන් හිත note දෙන්නේ. So this is more natural for me. ඒ කියන්නේ මම note එකක් ලියාගෙන ආවිලා ඒක බලන් English වලින් note එක dictate කරන්නේ නැහැ. I don't do like that. Right? So very leisurely you learn. I have a very proper plan. මම කිව්වේ මෙච්චර class days ගණක් මෙහෙම ගන්න කියලා. ඒ plan එකට මම කියනවා you can evaluate me. බලන්න මම කොච්චර මගේ plan එකට වැඩ කරනවද කොච්චර මගේ වැඩ quality and පිළිවෙලයිද කියලා. You can evaluate my quality and neatness, right? So this will be a very, very smooth journey for you during your A-level stay with me. Right? Follow this with 100% confidence. You are getting the premium stuff when compared to all your friends who are attending little classes. I mean, they are lecturers, they are tutors, they don't face the mainstream competition. They isolate somehow, do some little English medium classes. No point of attending to them, right? They are not getting the mainstream spirit, they are not feeling the mainstream competition, nothing when they attend to that kind of classes. So please follow this and you will get the premium stuff and the premium results as well. Right, you can check whether they've learnt about these nuclides. You check whether they've learnt about these isotopes, the stability belt or whatever. You check whether they know nuclear stabilization process. Just ask, have you learned this? And you check whether they can evaluate what is more stable isotope when two isotopes are given to compare the stability. You check whether they can achieve that kind of objectives. Then for the moment, it's 1 month old, yet you will feel that you know something better than them. You have cutting edge advantages having a lot of theories where your friends they don't know. අනික් අය දන්නේ නැති theories ටිකක් අනික් අය දන්නේ නැති logics ටිකක් ඔයා දන්නවා කියන confidence එක පුතා ඔයාට දැම්ම මෙයි. ඔයාලා touch කරලා තියෙන modern parts ඒගොල්ලෝ touch කරලා නැහැ. මේවා out of syllabus නෙමෙයි. ඒගොල්ලන්ගෙන් ඇහුවොත් කියයි ඒගොල්ලන්ගේ සර්ලගෙන් අහලා වලට these are out of syllabus, these are very advanced stuff. Since he's a chemical engineer, he's giving you very advanced stuff. Likewise, no, these are not advanced stuff. Those are not out of syllabus one. And out of syllabus ne. For that, I have given you the workbook and I have given you the PPQ book. You check. These have been tested in your term tests. These have been tested in past paper A-level questions. Understood what I'm saying? You just show them. This is past paper. Hey, mate, see, this is a past paper book. These have been tested in past paper. So you are not learning this stuff means you are getting lack of theories. So have that confidence. You are getting the premium stuff. So we'll maintain this vibe throughout the course. Right? So that you can directly ask whatever. Or one question directly ආන්නත් මං ඉඩ දීලා දිනවා. Group එකේ අහන්න පුළුවන්, physically නේද class එකෙන් පස්සේ හම්බෙලා අහන්න පුළුවන්. Get the maximum out of me. මගෙන් ගන්න පුළුවන් උපරිම වගේ life එකට ගන්න. That's what I want. Right, Puda. Anyway, right, we are talking about the belt of stability. Right, now we know what are nuclides and what is happening within the nucleus based on the effectiveness of the nuclear stabilization process. How nuclides are being classified as in the form of naturally occurring stable ones, naturally occurring unstable ones, and artificially generated unstable ones. Right, what nuclear scientists they did was they used number of neutrons number of neutrons available within the nucleus to y-axis, and they positioned number of protons available to x-axis. ඒ කියන්නේ පුතා මේ නියුක්ලියර් සයන්ටිස්ට්ලා මෙහෙම වැඩක් කරා. හරි ඒගොල්ලෝ මේ ලෝකේ හොයාගෙන තිබිච්ච නියුක්ලයිඩ්ස් වල there are about 300-400 nuclides available. ඒ දැන් අපි ගත්තොත් එහෙම hydrogen has 3 different nuclear compositions නේ. H11, H12, H13. Likewise we have 100 to 110 elements all together. මේ වෙනකොට ලෝකේ elements 100ක් 110ක් හොයාගෙන තියෙනවා. Each of these elements have got 3 to 4 different nuclear compositions. They could form 3 to 4 different nuclides. So 100 into 4 means we have altogether we have around 400 different compositions, 400 different nuclides available in the chemistry. Chemistry lo menoko nuclides 400ක් විතර තියෙනවා. What they did was they plotted number of neutrons available in a given nuclide to y-axis, number of protons available in a nuclide to x-axis, and they developed a plot. ඒ කියන්නේ මෙන්න මෙහෙම plot එකක් ගත්තා. දැන් හිතන්නකෝ ඔයා nuclide එකක් ගන්නවා. ඒ nuclide එකේ protons 3යි neutrons 4යි කියලා හිතන්නකෝ. So the x coordinate would be 3. Number of protons available in that nuclide is 3. The y coordinate would be 4. Number of neutrons 4යිනේ. එතකොට 3,4 කියන point එකෙන් තමයි ඒ nuclide එක denote වෙන්නේ. අපිට තේරෙනවනේ මම කියන එක. Let's say you are taking another nuclide with 11 protons and 13 neutrons. So what would be the x coordinate? 11 protons ne, 13 neutrons ne. What would be the y coordinate? 13. So 11,13 කියන point එකෙන්, right, coordination point එකෙන් ඒ nuclide එක denote කරන point එක අපිට හම්බ වෙනවා. Got what I'm saying? එතකොට මේ ලෝකේ nuclides 400ක් හොයාගෙන තියෙනවා නම් මේ හොයාගෙන තියෙන nuclides 400 මේ විදිහේ identical points 400කින් represent වෙනවා. මේ විදිහේ identical point 400කින් represent වෙනවා. මෙන්න මේ විදිහේ identical points 400කින් represent වෙනවා. Hope you got what I said. නේද? මේ විදිහේ identical points 400කින් represent වෙනවා. හරි. ඒගොල්ලෝ කරේ, right, what they did was මේ nuclear scientists ලා කරේ අර naturally occurring stable nuclides ටික denote කරන points ටික මෙහෙම එක color එකකිනුයි එක විදිහකටයි naturally occurring unstable nuclides ටික denote කරන point ටික තව color එකකිනුයි naturally occurring unstable nuclides ටික denote කරන points ටික මෙහෙම තව color එකකිනුයි artificially generated stable unstable nuclides ටික denote කරන point එක මේ විදිහට තව color එකකිනුයි මෙන්න මෙහෙම plot කරා. ඒගොල්ලෝ කියවනේ nuclides වර්ග තුනක් තියෙනවා කියලා. That's what they believed no. එතන ඒ believe කරපු nuclides වර්ගවල naturally occurring stable ones එක color එකකිනුයි එක විදිහකටයි naturally occurring unstable ones එක විදිහකටයි artificially generated unstable ones එක විදිහකටයි they එක ක්‍රම වලට plot කරා. හරි. ඒත් එක්කම මේ reference line එකක් විදියට n equals p line එකත් ඒගොල්ලෝ plot කරා. This is n equals p line. What do you mean by n equals p line? මොකද n equals p line එක කියන්නේ? 1 1 2 2 3 3 4 4 7 7 9 9 අර n විගේ neutrons ගන්නයි protons ගන්නයි equal points ටික connect කරපුවම එන line එක. ඒක reference line එකක් විදියට ගත්තා n equals p line එක ගත්තා. Right. ඒගොල්ලන්ට පෙවුන පුතා they could observe මෙන්න මේ naturally occurring stable nuclides ටික denote කරන points ටික හරි naturally occurring stable nuclides ටික denote කරන point ටික මෙන්න මෙහෙම tiny belt එකකට concentrate වෙලා තියෙනවා කියලා ඒගොල්ලෝ දැක්කා. මේ වගේ tiny belt එකකට concentrate වෙලා තියෙනවා කියලා they saw. එහෙම tiny belt එකකට concentrate වෙලා තියෙනවා කියලා ඒගොල්ලෝ දැක්කා. අර naturally occurring stable nuclides ටික concentrate වුණු belt එක කියන අදහස ඇතුව, right, with the meaning of the belt where naturally occurring stable nuclides are being concentrated, they named this particular belt as the belt of stability. The belt of stability. This is known to be belt of stability thereafter. So that is called the belt of stability. So we can see the composition of stable nuclides, stable nuclei of given elements. Right. I may continue my writing, or actually reading. The stability bar appears when the number of neutrons contained in all the atomic nuclides discovered so far is plotted in y-axis, and the number of protons on the x-axis කියලා එන්න ඕනේ පුතා. x කියන letter එක type වෙලා නැහැ. Number of protons on the x-axis is imaginatively limited to the point used to stable nucleons. නෑ ඒක ගැලපෙන්නේ නැහැ. We have to recorrect it. The stability bar නෙමෙයි stability belt කියලා දාගන්න පුතා. bar කියන වචනේ belt කරගන්න. The stability belt appears when the number of neutrons contained in all the atomic nuclides discovered so far is plotted in y-axis, and the number of protons on the x-axis is imaginatively limited to the point used to represent the stable nucleus. Whatever, we got the idea, no, we don't need to recorrect it. Right, you have the plot. හරි, එතකොට මේ plot එක නිකන් මෙන්න මේ වගේ. I'll be sharing you an actual image as well. මම actual image එකක් share කරන්නම්. The plot is like this. Wait. Right, the plot is like this පුතා. I don't know whether it is very clear to you. මේකේ colors අවුල් but OBS එක through අවුලක් නැහැ නේ. live එකේ ඉන්න අයට මම හිතන්නේ අවුලක් නැහැ. Physical students, right, it's like this පුතා. So we have two regions. Anyway, it's plot like this, right? We'll move into this one. It's like this, right? So you have this kind of a diagram where when you observe it closely, you will see a warm kind of line goes like this. You can see, right? That kind of line is there, right? So label it the belt of stability. The belt of stability. And n equals p line must also be shown. n equals p line එකත් පෙන්වන්න. belt of stability කියන එක මාක් කරලා පෙන්වන්න අර dark color එකෙන් තියෙන say n equals p line එක කියන එක මාක් කරලා පෙන්වන්න. belt of stability n equals p line ඒ දෙක මාක් කරලා පෙන්වන්න. The belt of stability n equals p line. So this line මේ line එක දිගේ තියෙන dots වලින් පෙන්වන nuclides කියලා කියන්නේ මේ ලෝකෙ naturallyම හැදිලා තියෙන nuclear stabilization mechanism එක effectivelyම occur වෙන stable nuclides, stable nuclei. ඔතන මම කියන එක තේරෙනවනේ මේ point එකෙන් පෙන්නන ඒවා. හරි, අන්න ඒ වගේ composition එක බලද්දි we could observe four main things. Having look at their compositions. Look at this. By analyzing the stability belt, they could observe a specific n upon p ratio values to be having a coordination with number of protons in stability optimization process. They can see different n upon p ratio values under different number of protons ranges when they are analyzing this stability belt. Right. 4 observations were there. I'll tell you first of all. Right. They could see nuclei where the proton number is within the range of 1 to 20. Again, protons එකත් 20ත් අතර තියෙන nuclei. They found to be getting stabilized when n upon p ratio reaches 1. n upon p ratio එක කීයට ලං වෙනකොටද stabilize වෙලා තියෙන්නේ? එකට ලං වෙනකොට. When this ratio becomes 1. Nuclei with number of protons within the range of 21 to 40, they become stable when n upon p ratio reaches 1.25. කීයට reach වෙනකොටද? 1.25 වලට n upon p ratio එක reach වෙනකොට stabilize වෙනවා කියලා හොයාගෙන තියෙනවා. Nuclei with number of protons in the range of 41 to 60. 41 to 60 range එකේ protons තියෙන ඒවා. They become stable when n upon p ratio reaches 1.40. Nuclei with more than 60 number of protons, they tend to become stable when the n upon p ratio figure reaches 1.5. 1.5. මේ observations හතර ඒගොල්ලන්ට දකින්න හම්බුණා. හරි. අපි ওই හතර ලියමු. ඔය left hand column එකේ තියෙන ඉඩේ මේ observations ටික අපි ලියමු. right. ලියන්න. පළවෙනි point එක මෙහෙම. right. You may write down. Nuclei, nuclei with 1 to 20 number of protons, 1 dash 20, you may bracket it up. මෙම range එකක් විදිහට bracket කරලා පෙන්නන්න. Nuclei with 1 to 20 number of protons. Nuclei with 1 to 20 number of protons tend to become stable, TEND, tend to become stable, tend to become stable when tend to become stable when n upon p ratio reaches 1.00. n upon p ratio reaches 1.00. n upon p ratio reaches 1.00. Right. Second point. Nuclei with number of protons 21 to 40. Nuclei with number of protons 21 to 40. Nuclei with 21 to 40 number of protons, I would say in that manner, 21 to 40 number of protons tend to become stable, tend to become stable when n upon p ratio reaches 1.25. n upon p ratio reaches 1.25. n upon p ratio reaches 1.25. Third point. Nuclei with 41 to 60 number of protons. Nuclei with 41 to 60 number of protons nuclei with 41 to 60 number of protons. Nuclei with 41 to 60 number of protons tend to become stable when n upon p ratio reaches 1.40. When n upon p ratio reaches 1.40. When n upon p ratio reaches 1.40. Fourth point, හතරවෙනි bullet point එක, last one. ඔක ලියපුවම මේ paragraph එකේ ඒ column එකේ වැඩ ඉවර වෙනවා. Nuclei with more than 60 number of protons. Nuclei with more than 60 number of protons becomes stable. Nuclei with more than 60 number of protons become stable when n upon p ratio reaches 1.50. When n upon p ratio reaches 1.50. Right, so that is it. So this theory will be tested in your exams in a different manner. මේක පුතා මෙහෙම directly gediya පිටින් අහන්නේ නැහැ. මේක indirectly තමයි ඒගොල්ලෝ questions වල අහන්නේ. ඒතකොට මේක exam එකේ අහන pattern එක identify කරගන්න අපි examples 3-4ක් කරමු. අර අපේ කොළ set එක ගන්න. අරගෙන ඒකේ දාන්න subtopic එක Roman number 2 the belt of stability කියලා. දාලා අපි examples 3-4ක් විතර එතන කරමු. අර කොළ ටික ගන්නකො අරගෙන දාන්න Roman number 2 අගෙන අපි nuclides කියන unit lesson එකේ ඉන්නේ. ඒකේ subtopic Roman number 2 second subtopic එක the belt of stability. The belt of stability. Right, the belt of stability. Hari ලියන්න example 1. Example 1. ලියන්න මේ example 1. Compare the relative stabilities of compare the relative stabilities of carbon 612 and carbon 614 isotopes. Carbon 612 and carbon 614 isotopes. Compare the relative stabilities of carbon 612 and carbon 614 isotopes. හරි. මෙන්න මෙහෙම තමයි පුතා අහන්නේ. මේ nuclides කියලා දාන isotopes කියන වචනේ තාම අපි ඉගෙන ගත්තේ නැති හින්දා same thing but you may put the word nuclides. Compare the relative stabilities of carbon 612 and carbon 614 nuclides. We'll put it in that way. 612 and 614 nuclides. Hari, listen to me very carefully. ළමයි This is how that is been tested. ඒක ටෙස්ට් කරන්නේ මෙන්න මෙහෙම. හරි. So we are supposed to determine the stabilities of these two nuclides. See, carbon 612 nuclide has an N upon P ratio figure equals to 6 divided by 6, which is 1.00. හරිනේ? Carbon 614 isotope has N upon P ratio figure 8 divided by 6 means 1.33. Right? Right. Pudha, you tell me based on your theory book, both these nuclides are having 6 number of protons, means they are in the range of 1 to 20. Number of protons available in the nuclide is 1 to 20 in the range. Am I correct? Right. So what we learned, මොකද අපි ඉගෙන ගත්තේ? They tend to be stable when N upon P ratio reaches what? කියන්නකෝ කෑගහලා. Please talk, will you? When N upon P ratio reaches what? Read, 1.00. So which is having more closer figure to 1.00? Is it carbon 612 or carbon 614? 612. Hence, what we can say, how we can conclude the fact? We can conclude the fact that carbon 612 nuclide is more stable when compared to carbon 614 nuclide. You got what I said? So that's how we construct the answer for this kind of questions. This is how we have been tested. Right. You may write down the answers. මම දැන් පළවෙනි එකේ ආන්සර් එක ඔයාලට දෙන්නම්. ඉස්සෙල්ලාම ලියන්නකෝ මැද්දෙන් මේ nuclides දෙකේ N upon P ratios ටික. Carbon 612 වල 1.00, carbon 614 වල 1.33. 1.00, 1.33. හරි. ලියන්න paragraph එකක මෙහෙම, හරි? para එකක ලියන්න. Right. You may write down under a paragraph. Since both these nuclides are having protons in the range of 1 between 20, okay, 1-20 කියලා දාන්න. Since both these nuclides are having protons in the range of 1-20, within brackets you may write it properly. Since both these nuclides are having protons in the range of 1-20, carbon 612 nuclide, which has more closer figure to 1.00, carbon 612 nuclide which has more closer figure to 1.00, carbon 612 nuclide which has more closer figure to 1.00 can consider to be more stable, can consider to be more stable, can consider to be more stable, which has more closer figure to 1.00 can consider to be more stable. එක more stable කියලා අපිට කියන්න පුළුවන්. Can consider to be more stable. හරි. මම දැන් examples දෙකක් දෙනවා. තනියෙන් calculations ටික කරලා answer එක ලියලා you have to present your answer. Right? Example 2. දැන් එකකට යන ඉඩ ටික තේරෙනවනේ, you know how much of room it's consumed. ඒකත් බලලා examples දෙකම ලියලා එක සැරේ කරන්න. Right, example 2. Compare the relative stabilities of 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 oxygen 816 and oxygen 818 nuclides. oxygen 816 and oxygen 818 nuclides. Right. You may leave the space. Example 3. Compare relative stabilities of bromine 3579 and bromine 3583 nuclides. Bromine 3579 and bromine 3583 nuclides. 3579 and 3583 nuclides. Hurry. 5 minutes will be given. You have to come up with your own answers. Come on, Lamai, do it. I need you guys to come up with thorough answers. Come on. You have to calculate N upon P ratio figure for each of these nuclide, and then you see number of protons available within which range. Is it 1 to 20, 21 to 40, 41 to 60 or above 60? Then based on the benchmark figure, you can come up with the most stable one. Right, come on Lamai, do it. I need you guys to construct your answers. Present is nicely. This is how this has been tested in your exam papers and all. Live එකේ ඉන්න අය You just put your answers. I need to see your answers as well. Third example එකේ කවුද most stable කියලා දාන්න. According to you, is it bromine 83 or bromine 79? Second එකේ, is it oxygen 18 or oxygen 16? I need your answers lamai. Come on. There are hundreds of you guys. You have to come up with your answers. And physical students also. Physical inna lamai tikat. I need your answers. Come on lamai. Done. Done. Lamai, listen to me. Here guys, come on. 0816, the N upon P ratio figure is 8 divided by 8, which is 1. The N upon P figure is 10 divided by 8, which is 1.25. Am I correct? Right. So, both these nuclides are having protons in the range of 1 to 20. They have 8 number of protons, which is happening in the range of 1 is to 20. Right. So the nuclide where N upon P ratio reaches 1.00 becomes more stable. That's what we believe. So which is having more closer value to 1.00? It's oxygen 816. Oxygen 816 nuclide can consider to be more stable. Right. Raise your hands if you got the correct answer. Raise your hands if you found oxygen 16 to be the most stable one. Super. This is little bit complicated when compared to earlier ones. You have to come up with more precise calculations and all. Bromine 3579 has 44 neutrons and 35 protons, where the N upon P ratio becomes 44 divided by 35 means 1.990. We have 2, 70, 20. For 200 we have, is it 6 when we round off to 2 decimal places? Yes, right? Here we have N upon P ratio figure 48 divided by 35. 1.130 means it's 3, I guess. Right, 105, 25. For 250, it's almost 1.38, right? Is it 1.37 or 1.38? Is it 7? Right, 1.37. That's what I've been told. Right. Listen to me very carefully. Both these nuclides are having protons in the range of 21 to 40. Right. What we learned, go back and see what we learned. Where a particular nuclide is having a number of protons in the range of 21 to 40, they tend to be stable when N upon P ratio reaches 1.25. That's what been told. So which is having more closer value to 1.25? Is it bromine 83 or bromine 79? Bromine 79, right? So bromine 79 isotope can consider to be the stable one. Am I correct, Pudha? This is considered to be most stable one. I saw the correct answer from most of the guys who are in the live as well. That's super, right? So these are the answers for this one. This is how the knowledge on nuclide is being tested. Understood how they test and how to present your answers? තේරුණා වැඩේ එළියට දාන්න විදිය? හරි. මම විනාඩි 5ක් දෙනවා. ඒ විනාඩි 5 ඇතුලේ සම්පූර්ණයෙන් නියුක්ලයිඩ්ස් කියන ටොපික් එකේ අපි අර එක්ස්ට්‍රා ෂීට්ස් වල කරපු එක්සර්සයිසස් උයි අරව මේව ඔක්කොමත් එක්ක ෆුල් නෝට් එක කියවන්න. නියුක්ලයිඩ්ස් පාර්ට් එක ඔච්චරයි. ෆුල් නෝට් එක එක සැරයක් ටක් ගාලා කියවන්න හැමෝම. Right. Full note එක ඉස්සරහ කියවන නියුක්ලයිඩ්ස් පාර්ට් එක ඔච්චරයි. We'll summarize whatever the things been learnt and we'll move on to nuclear reactions part. Right, we'll move on. Clear up until now? You guys, clear? Raise your hands if it's very clear for you. Fine. Hurry. Lamai, is it clear for you? I need responses from everyone, every single one. Okay, super. Right, Lamai, I'll anyway summarize whatever the things been taught because we had a 2 hour session up until now. We had 2 hours. So, mange padeke karabuti summarize karanna. Harid? Hari. It's like this, Lamai. Right. We studied about nuclides. Right. Nuclide means something where the nuclear composition is known. The nuclear composition means number of neutrons and number of protons available within the nucleus is known. Right? If we know the nuclear composition of any kind of an species, that can be said as a nuclide. Right? This definition for nuclide came up with Koman in 1940s. Further, Koman classified nuclides into 3 subcategories where naturally occurring stable nuclides, naturally occurring unstable nuclides, artificially generated unstable nuclides can be seen. Right. This classification came up by evaluating the effectiveness of ongoing nuclear stabilization process of a given nuclide. The nuclear stabilization process involves with mesons, which are said to be charge carriers. They transport the positive charge of a proton to a neutron. They do it continuously so that it avoids generation of stable and steady repulsive forces within the nucleus and make the nucleus stable. Right. The effectiveness of this process would depend on 2 factors: number of protons available within the nucleus, the N upon P ratio value which related to the composition of that particular nucleus. Right. So based on that, based on evaluating that only, we can come up with naturally occurring stable type, naturally occurring unstable type, and artificially generated unstable type. That's all, right? Right. Scientists, they recognized these 3 types of nuclides and they plotted number of neutrons to be in y-axis, number of protons to be in x-axis of all these nuclides. Right. They used 3 different notations, symbolizing techniques for these 3 types, and they could observe the fact that stable nuclides, the points which represented stable nuclides, to be spread or distribute along with a tiny line which goes with n equals p line, which goes parallel to n equals p line at the beginning but move towards upward direction during the latter part of the distribution. කියන්නේ මුලින් n upon p line එක දිගේ ගිහලා පස්සේ මේ y axis එක පැත්තට හැරිච්ච පොඩි belt එකකට naturally occurring stable nuclides denote කරන points ටික concentrate වෙලා තියෙනවා කියලා ඒගොල්ලන්ට පෙවුනා. When they further analyzed these compositions, they could observe 4 facts. 1. Protons එකත් 20ත් අතර තියෙන nuclides n upon p ratio එක 1.00 reach වෙනකොට stabilize වෙනවා කියන එක. 2. Protons 21ත් 40ත් අතර තියෙන nuclides n upon p ratio එක 1.25 වෙනකොට stabilize වෙනවා කියන එක. 3. Protons 41යි 60යි අතර තියෙන nuclides n upon p ratio එක 1.40 වෙනකොට stabilize වෙනවා කියන එක. 4. Protons 60ට වඩා තියෙන nuclides n upon p ratio එක 1.5 reach වෙනකොට stabilize වෙනවා කියන එක. We performed several examples and calculations to thorough these theories in our mind. අපි පොඩි වැඩ ටිකක් කරා මේ ටික concrete කරගන්න. That's all we did under nuclides. Am I correct, Lamai? Yes or no? Talk louder. Say loud as much as you can. Yes or no? More. ඔන්න කැඳ බීලා වගේ ඉන්නේ. හරි? Right. Anyway. New topic. Nuclear reactions. We have to study about nuclear reactions. Right. Puda. Nuclear reactions means a very complicated area of study. Where in A-level chemistry syllabus, we don't need to come up with nuclear reaction classification, types of nuclear reactions, why are these different types? No, we don't need to go through, right? We simply need to balance a given nuclear reaction. That's what expected from you guys. What do we need to do? අපිට මොකද කරන්න තියෙන්නේ A level chemistry syllabus එකේ? Simply a balanced nuclear reaction. How to balance a nuclear reaction. That's what expected from you, right? ඒක වාට හිතෙන්න පුළුවන් අපෝ සර් simple needs nothing no. මේ පැත්තේ බැලුවා මේ පැත්තේ බැලුවා මේ coefficient එකක් දැම්ම balance කරා කියලා. ඒ කියන්නේ දැන් හිතන්නකෝ if I'm asking you guys to balance this equation, what you would do? මේක balance කරන්න කියලා මම දුන්නොත් what do you do? මොකද්ද ඔයා කරන්න කියන්නේ මට? You simply observe and balance. Am I correct? You see, 2 nitrogen atoms are there in the left hand side. What do we need to do is, you put 2 here. When you put 2 here, 2 into 3, the number of hydrogen atoms available becomes 6. To balance it out, you put 3 here. So this is balanced. This is what you do, right? Am I correct? එකත් බැරි නෑනේ පුළුවන් නේ එක. හරි. Right. So that is what you do, right? Right. But you can't balance nuclear reactions in that way. Nuclear reactions are like this, Buddha. Beryllium 49 plus alpha 24 will give you carbon 612 plus X dot dot. So you are supposed to determine these figures. That's what called nuclear reaction balancing. You can't simply see, see number of beryllium atoms available in the left hand side is 1. So we have to balance this for 1. When you go looking at this stuff, you can't find beryllium there. The atomic structure changes. The elements convert into another elements. Those crazy things happens when nuclear reactions are happening. Understood what I'm saying? So this is not simple balancing like this. Make අර වගේ simple balancing එකක් නෙමෙයි. For balancing this kind of nuclear reactions, you need to know 2 theories. How many theories to be known? 2 theories දෙකක් අපි දැනන් ඉන්න ඕනේ. One is charge conservation law. කෑ ගහලා කියන්න මම කෑ ගහන්න බෑනේ. පුළුවන් විදිහට කියන්නකෝ. First one is what? Charge conservation law. The second one is mass conservation law. What is the second one? Mass conservation. If a given nuclear reaction obeys charge conservation law and mass conservation law, that is said to be balanced. We can't one-to-one balance. Beryllium ekai. No, that is not possible. Right? That is impossible. So මේ දෙක obey වෙනවා නම් ඒක අපි කියනවා balance nuclear reaction එකක් කියලා. හරි. We'll move with the note. අපි note එකත් එක්ක ඉස්සරහට යමු. Subtopic simple B nuclear reactions. A nuclear reactions වල definition එක page 9 එකේ right hand column එකේ උඩ තියෙනවා. See. Nuclear reactions are specific reactions which emits alpha, beta, gamma. We are learning this stuff later. Radiations or absorbing other subatomic particle species to stabilize unstable. ඒ කියන්නේ පුතා මේ unstable nuclides stable nuclides වෙන්න subatomic particles hari alpha, beta, gamma කියන types වල radiations hari emit කරලා hari absorb කරලා hari perform වෙන reactions අපි කියනවා nuclear reactions කියලා. මේ definition එක පොඩ්ඩක් adjust වෙන්න ඕනේ. අපි මෙහෙම correct කරමු ඒක වැරදි. Nuclear reactions are specific reactions which emits or absorbs. Emilian, which emits or absorbs. Emits කියන තැන emits or absorbs. Which emits or absorbs alpha, beta and gamma radiations or ඊට පස්සේ absorbing කියන වචනේ කපන්න. Other subatomic species. Alpha, beta, gamma radiations or absorbs කියන වචනේ කපන්න. Other subatomic species. To stabilize the unstable nucleus. Nuclei පුතා. Plural. Nuclei. NUCLEI. US කියන අකුරු දෙක කපලා I කියලා දාන්න. Nuclei. හරි. Whatever. Only the knowledge regarding balancing of below nuclei reactions is considered in A-level scope. 2 main conservation principles are used for that. Right? How many conservation principles are being used? Two conservation principles are being used. Only the balancing is expected. Right? හරි. අපි ලියමු නිකන් චූටි subtopics දෙකක්. We have enough room there. Right? නිකන් තරුවක් දාලා පොඩි subtopic එකක් විදිහට ලියමු. මෙන්න මේක තමයි පළවෙනියෙන්ම use කරන rule එක. Charge conservation law. Charge conservation law. Charge conservation law. Charge conservation law. හරි. ළමයි අපි එක ලියමු ලියන්න charge conservation law කියලා දාලා මේ මෙන්න මෙහෙම double commas ඇතුලේ ලියමු. හරි? double commas ඇතුලේ ලියමු. ඒ කියන්නේ මේ law එක ලියන්න යන්නේ අපි. හරි. ලියන්න ඉස්සෙල්ලා. Listen to me. You know what is charge conservation law? It's very simple. The proton number of left hand side of the nuclear reaction must be equal to the proton number of right hand side of the nuclear reaction. That is called charge conservation law. You know, the proton number of the left hand side is 4 plus 2, which is 6. The proton number of right hand side is 6 plus Z. So Z must be what then? C must be 0. Got what I am saying? ඒක තමයි charge conservation law එක කියලා කියන්නේ. right. ලියන්න double comma ඇතුලේ මෙහෙම total proton number of left hand side of the nuclear reaction, total proton number of left hand side of the nuclear reaction, left hand side of the nuclear reaction, total proton number of left hand side of the nuclear reaction, left hand side of the nuclear reaction must be equal to the total proton number of right hand side of the nuclear reaction, must be equal to the total proton number of right hand side of the reaction, total proton number of right hand side of the reaction, right hand side of the reaction. Double commas 1. So that is conservation law of charge, and charge conservation law. Right. The second one, mass conservation law. Mass conservation law. Mass conservation law. පුතා mass conservation law එක කියලා කියන්නේ ඕකෙම අනිත් පැත්ත. The total number of mass number within the left hand side of the reaction, which is 9 plus 4, 13, must be equal to the total mass number of the right hand side of the reaction, 12 plus A. Then you can determine A to be 1. තේරුණේ මං කියන්නේ? ඒතර ඔන්න ඔය ෆිගර්ස් දෙක දෙපැත්තේ බැලන්ස් නම් ඒකට කියනවා බැලන්ස් නියුක්ලියර් රියැක්ෂන් එකක් කියලා. හරි? හරි. ලියන්න ඩබල් කමාස් ඇතුලේ මෙහෙම total mass number of left hand side of the equation, total mass number of left hand side of the equation total mass number of left hand side of the equation, total mass number of left hand side of the equation, total mass number of left hand side of the equation must be equal to the total mass number of right hand side of the equation, total mass number of right hand side of the equation. Total mass number of right hand side of the equation. Right. පුතා page 9 වල මේ left hand side column එකයි right එකේ 1/3 විතරයි ඔයාට ඉඩ තියෙනවා. මෙන්න මේ examples පහ කරන්න තියෙන්නේ. මම පළවෙනි මිස් වෙලා තියෙනවා හැම එකකම mass number එකකුයි charge number එකකුයි proton number එකකුයි. ඉතින් මිස් වෙලා තියෙන mass number එකයි proton number එකයි හොයන්න තමයි තියෙන්නේ. හොය balance කරලා ඒ දෙක හොයන එක තමයි task එක. මම එකක් කරලා පෙන්නන්නම්. එතකොට අනිත් ටික ඔයාලට කර හැකියි. හරි? හරි. Look at this පුතා. Right. Look at this. Don't try to do it by yourself. Just see what I'm doing. පළවෙනි example එකේ තියෙන්නේ carbon 614 gives you nitrogen something plus E minus 1 0. E minus 1 0. මෙන්න මේකේ මේ මිස් වෙලා තියෙන mass number එකයි charge number එකයි determine කරන්න තමයි දෙන්නේ. හරි හැම වෙලේම මිස් වෙලා තියෙන charge number එක ගන්න Z කියලා mass number එක ගන්න A කියලා. That's how we usually denote. හරි. එතකොට දැන් මෙහෙමයි කරන්නේ. හරිද? ඉතුරු හතරවා තනියෙන් කරන්න ඕනේ. Just look at this. එතකොට ඔයා apply කරන්න theories. එතකොට මම ඉස්සෙල්ලාම apply කරන්නම් charge conservation law එක මේ. By applying charge conservation law. By applying charge conservation law, come on, what you get is 6 equals Z plus minus 1. Then we simplify karamu mentally. Z becomes 7. Harima. Ilangata by applying mass conservation law, by applying mass conservation law, come on, what do we get is 14 equals A plus 0, then A becomes 14. ඔන්න ඔය විදිහට මේ මිස් වෙලා තියෙන mass number එකයි මිස් වෙලා තියෙන charge number එකයි determine කරන එක තමයි කරන්න තියෙන්නේ. හරි? right එහෙනම් page number 9 වලට පයින්න උඩ තියෙන එකේ example 1 කියලා දාලා මේ විදිහට ලියලා මිස් වෙලා තියෙන numbers ටික මේ විදිහට determine කරන්න. හරි. ඔය විදිහටම ඉතුරු හතර කරන්න. You have enough space there. You don't need to take your extra papers for that. Finish off. Nitrogen 714 plus helium, it has to be recorrected, but it's wrong. It has to be 24. A type setting mistake එකක් තියෙන එක හදාගන්න. හරි? right. Oxygen space plus hydrogen 11. Radium 88, mass number is missing. Helium 24 plus, radon 222 something, arsenic one part is missing 73, E minus 10 gives you germanium 32 something, F919 plus X, two parts are missing, nitrogen 716 plus helium 24. Harry. These missing mass numbers and charge numbers must be found. Right. Come on, Laman. Take your time. You have enough time. Find these missing numbers. Missing charge numbers must be denoted as Z or C. missing mass numbers must be denoted as A. Right. Take your time, do it leisurely. hope you are done with the stuff, right? Let me, here, by applying charge conservation law, 7 plus 2 equals Z plus 1. Z becomes 8. 14 plus 4 equals A plus 1. A becomes 17. So, C 8, A 17. Am I correct? Right. Second one. By applying charge conservation law, 88 equals 2 plus C. C becomes 86. A equals 4 plus 222. A equals 226. Am I correct? Yes. This one. C minus 1 equals 32. C becomes 33. 73 plus 0 equals A. A equals 73. Am I correct? So this is 33. This is 73. Last one. By applying charge conservation law, 9 plus C equals 7 plus 2. C equals 0. 19 plus A equals 16 plus 4. A equals 1. 0, 1. Am I correct? Yes. Fine. Super. That's it. That's it for nuclear reactions. Was everything clear? Yes or no? Yes. Right. Was everything clear, Lamai? Yes, all correct. Good. Is everything clear? Yes or no? Yes, 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 yes. Fine, fine. We'll move on to one more subtopic and finish off. තව එකක් කරලා ඉවර කරමු. Radioactivity. Radioactivity. Right. Right, Lamai, listen to me, listen to me. Radioactivity means what? Radioactivity means emission of radiation which can ionize gases plus can penetrate stuff. කියන්නේ දේවල් හරහා penetrate කරන්න පුළුවන්. gases ions වලට convert කරන්න පුළුවන්. gases ionize කරන්න පුළුවන්. radiations emit කරන්න සමහර elements වලට තියෙන capability එක, that phenomena එක, the overall scenario is named to be radioactivity. Right. Person Henry Becquerel claims the credit of discovering this radioactivity. Who's the person? Henry Becquerel claims the credit of discovering radioactivity. But there were two guys, Marie Curie and Pierre Curie. They assisted Becquerel in coming up with this radioactivity concept. Right? Radioactivity is the process of emitting radiations with gas ionization capability and penetrating capability. Capability, not the capacity, I would say capability. Penetration capability. Radioactivity is discovered by Henry Becquerel with the involvement of Marie Curie and Pierre Curie. Full stop. It has to be full stop there. Three major radiations are emitted from a radioactive element are alpha, beta and gamma rays. Radioactive element එකකින් release වෙන three major radiation types වෙන්නේ alpha radiations, beta radiations and gamma radiations වෙනවා. alpha, beta, gamma කියන radiations තමයි three main types of radiations. හරිද? right. අපි මේ alpha, beta, gamma කියන radiation types ගැන පොඩි විස්තරයක් will study. right පුතා, alpha radiations means, right, alpha radiation means propagation of particles which consist of two protons and two neutrons in the half speed of light. Again, light එකේ speed එකෙන් half speed එකකින් light එකේ speed එක අපි කියන්නේ c කියලා. You know what the figure of c? මොකද light එකේ speed එකේ figure එක? 3 into 10 to the power of 8 meters per second. Am I correct? ඒකෙන් half speed එකකින් 0.5 c කියන speed එකකින් protons දෙකකුයි neutrons දෙකකුයි. ඒතර protons දෙකයි neutrons දෙකයි කියන්නේ charge එක දෙකයි. protons දෙකයි කියන්නේ charge එක දෙකයි. protons දෙකයි neutrons දෙකයි කියන්නේ mass number එක 4යි. මෙන්න මේ type එකේ helium nucleus එකක් වගේ. helium atom එකක nucleus එකත් ඒ වගේ. protons දෙකයි neutrons දෙකයි තියෙන්නේ. helium nucleus එකට identical protons දෙකකුයි neutrons දෙකකුයි තියෙන particles 0.5 c speed එකෙන් propagate වෙනකොට that is known to be alpha radiation. හරි? We compare two main qualities of this radiation, penetration capability and gas ionization capability. When it comes to gas ionization capability, this alpha radiation has highest gas ionization capability. When it comes to penetration capability, ability to penetrate something, this has the minimum penetration capability. Highest gas ionization capability and minimum penetration capability is there. Beta radiation means propagation of electrons. Electrons, you know, charge is -1, mass is 0. Electrons වලට mass එකක් නැහැ කියලානේ අපි අර ගිය සතියේ වගුවකට short note එකක් ගද්දි අපි කියන්නේ roughly the mass is believed to be 0 no, approximately, but the charge is -1, you know, right? So beta radiation means the propagation of electrons where the charge is -1 and the mass is negligible at the speed of 0.9 c. It means 90% of the velocity of light. 0.9 c, 0.9 into 3 into 10 to the power of 8 is believed to be beta radiation. Beta radiation කියලා ඒ speed එකෙන් electrons තමයි propagate වෙන්නේ. So this has moderate, mean වැඩිමත් නෙමෙයි අඩුමත් නෙමෙයි, moderate penetration and gas ionization capability. Penetration capability එකත් මෙයාලගේ moderate, gas ionization capability එකත් moderate කියලා අපි consider කරනවා. දෙකම moderate. Radioactive element එකකින් release වෙන gamma radiation means radiation of high frequency electromagnetic wave. Gamma radiation කියලා යන්නේ high frequency electromagnetic wave එකක්. particle එකක් නෙමෙයි. ඒ හින්දා gamma radiation particle එකකට charge එකක් mass එකක් නැහැ. 0 0 කියලා ලියලා තේරුමක් නැති හින්දා simply we write it gamma. Since this is an electromagnetic wave, gamma radiation කියලා නේ electromagnetic wave එකක් හින්දා එයාගේ propagation velocity එක c. light එකේ speed එකෙන් මෙයා propagate වෙනවා. මෙයාගේ velocity එක අනිත් දෙන්නගේ velocity එකට වඩා වැඩි හින්දා penetration capability is maximum. penetration capability එක maximum. මෙයාලගේ particle එකක charge එක 0 හින්දා මේ දෙන්නටම charge එකක් තියෙනවා හැබැයි මෙයාගේ charge එක 0 නේ. ඒ නිසා ionization capability is believed to be minimum. ionization capability එක minimum, penetration capability එක maximum කියලා අපි believe කරනවා. This is ionization capability. This is penetration capability. In this sense, c means the speed of light, which is 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. Right? We'll move on. අපි alpha rays ගැන අපි මේ කතා විච්චේව දෙනවද කියලා බලාගෙන යමු. Alpha rays travel at half times the speed of light, which are equivalent to the nuclei of helium atom, which consist of 2 protons and 2 neutrons. Alpha rays has a higher gas ionization capability as charge of a particle is higher, while has a lower penetrating capability due to its lower speed. Alpha rays can penetrate through materials such as paper. Alpha rays are only capable of penetrating through very soft materials like paper. And you remember Geiger Master's experiment? It went through a very thin gold foil as well. So very thin materials only can be penetrated. Beta rays are beam of electrons traveling at 0.9 times the speed of light. Beta rays has a higher penetrating capability than alpha rays, as beta particles are lighter than alpha particles, while beta rays has a lower ionization capability than alpha rays due to their lower charge. Beta rays penetrate through materials like aluminium sheets. Sheets කියලා දාගන්න. Like aluminium sheets. Aluminium foils කියලා දානවා FOILS. Like aluminium foils. ඒ බීටා කියන එකේ අන්තිම වර්ඩ් එක. Aluminium foils. FOILS. Right. Gamma rays. Gamma radiation is not a type of radiation with specific charge and mass, but it is an electromagnetic radiation with higher frequency. Gamma rays means not an emission of a particle, it is an emission of electromagnetic wave. Penetrating capability of gamma rays are higher as they are traveling in the speed of light, while has lower gas ionization capability. Gamma rays travel through materials like lead blocks. Lead block එකක් through උනත් penetrate කරන්න capability එක gamma rays වලට තියෙනවලු. Following table gives a comparative summary of basic characteristics of alpha, beta and gamma radiations. Alpha, beta, gamma radiations වල characteristic summary එකක් මේ table එකේ දෙනවලු. හරි. අපි මේ table එක fill කරමු. මේක තමයි මම මේ කරේ. Particles traveling in the radiation. Alpha වල දාන්න helium nuclei. Helium atoms වල nuclei එකේ composition එක තියෙන particles තමයි යන්නේ. පළවෙනි cage එක පුරවන්න helium nuclei. Right. Beta rays වල particles traveling in the radiation are electrons. Helium nuclei, beta rays වල electrons. Helium nuclei, electrons. Gamma වල particles flow වෙන්නේ නැහැ. ඉරක් ගහන්න. You put a dash. Gamma means electromagnetic waves. No particles are being flown. Relative charge of a particle, alpha has 2 protons. The relative charge is +2. Beta means electrons. Relative charge is -1. Since gamma do not contain any particles, you can't say a charge of a particle. You put a dash. Gamma means no particles. Relative mass of a particle, alpha, I would say 4u. I would write it in this way, Buddha. 4u. What do you mean by u? Your O-level science knowledge, if you have. U means what? U means, have you heard of this word? මොකක්ද ඒකට කියන්නේ? Atomic mass unit. Have you heard of it? No? Atomic mass unit, 1/12 of the mass of a C12 atom. That is represented by U. So alpha particle is having a mass of 4 times the mass of an atomic mass unit. It's called 4U. දැන් ඒක දන්නේ නැති හින්දා පැත්තකින් ලියන්න. යටින් ලියන්න කොහේ හරි C කියන එකයි U කියන එකයි දෙකම. U means atomic mass unit. U means atomic mass unit. මේකට කියන්නේ atomic mass unit කියලා. හරි. Anyway, symbol of a radiating particle. තොර charge එක 2යි mass එක 4යි හින්දා alpha rays වල symbol එක alpha 24. alpha 24. mass එක මේ alpha වල 4u පරින්න beta කියන්නේ electrons mass එක 0 electrons වලට අපි mass එකක් නැහැ කියලා තමයි ගන්නෙ 1 upon 1840 ද කොහෙද එන්නේ but it's negligible 0 gamma වල dash එකක් ගන්න මොකද gamma කියන්නේ particles නෙමෙයි ඒතර particulate mass එකක් කියන්න බෑ හරි symbol of alpha particle is alpha 24 symbol of beta particle is beta minus 1 you have everything in the board beta minus 1 symbol of gamma is gamma 00 or simply we can put gamma 00 or in simple terms it can be put gamma 00 or gamma right speed of radiation alpha 0.5 z beta 0.9 c gamma the propagation speed is c right penetration capability alpha minimum penetration capability alpha minimum beta moderate gamma maximum gas ionization capability alpha maximum because they are having highest charge particles flowing as in the form of radiation maximum beta moderate gamma minimum alpha maximum beta moderate gamma minimum right you have your extra paper set with you right අපි පොඩි පාර්ට් එකක් තියෙනවා ඒක කරලා ඉමු හරිද හරි ඒකේ දැන් අපි chapter 2 වල extra වැඩ ටිකනේ පුතා ඒ කොලවල කරන්නේ ඒකේ දාන්න subtopic C chapter 2 වල C කියන subtopic එක radio activity හරි chapter 2 වල C කියන subtopic එක radio activity කියලා දාන්න radio activity හරි ඒක අපි පොඩි extra note එකක් හදමු උතන ඉන්න නැති නිසා तो isotopes කියන part එකයි exercises උයි කරලා next week එකෙන් මම කිව්වේ class days දෙකක් මම consume කරනවා කියලානේ next week එකෙන් මම chapter 2 වැඩ ඉවර කරනවා හරි ඒතර වාගේ ඔය extra sheets වල දාන්න radio activity subtopic C කියලා radio activity හරිද දාලා ඒක අපි පොඩි extra note එකක් හදමු දාන්න note what is the meaning ලියන්න මේ note කියන එකේ topic එක deviation of alpha comma beta gamma radiation deviation of alpha beta gamma radiation through an electric field deviation of alpha beta gamma radiation through an electric field deviation of alpha beta gamma radiation through an electric field deviation of alpha beta gamma radiation through an electric field right listen to me Buddha right we are supposed to know deviation of these alpha beta and gamma radiation through an electric field you know what is an electric field මොකද්ද electric field එකක් කියලා කියන්නේ electric field එකක් කියලා කියන්නේ area between two oppositely charged plates එහෙම නේද අපි අර මතකද cathode rays වල properties වල electric field එකක් ගැන කතා කරේ මේ වගේ region එකකට තමයි electric field එකක් කියලා කියන්නේ. හරි. Listen to me පුතා. We must memorize, we must know, we must be capable of justifying, explaining radiation, the deviation of this alpha beta gamma radiation through an electric field. Electric field එකක් through යද්දි deviation එක කොයි වගේද කියන එක. හරි. Listen to me. Gamma rays කියලා කියන්නේ particles නෙමෙයිනේ. charge එකක් නැති electromagnetic waves නේ gamma rays කියලා යන්නේ. ඒතර gamma rays electromagnetic field එකක් through යද්දි deviation එකක් නැහැ. ගියපු විදිහටම යනවා. No deviation can be seen. Alpha rays consist of positively charged particles නේ. එහෙනම් ඒක deviate වෙයි මොන plate එක පැත්තටද? positive නම් positive plate එක පැත්තටද negative plate එක පැත්තටද? Right. Alpha rays, since they consist of positively charged particles, they deviate towards negatively charged plate. Beta rays, since they consist of negatively charged electrons, they deviate towards which plate? Positively charged plate, because oppositely charged particles are attracting to each other. So beta positively charged plate එක පැත්තට deviate වෙනවා. But here there is something to be remembered. It's like this, Buddha. From the same distance, deviation towards negative charge, deviation of alpha towards negative charge, I would say deviation of alpha means d alpha is less when compared to deviation of beta towards positive charge. See, d beta is greater than d alpha. That has to be justified as well. මේකත් අපි justify කරන්න ඕනේ. ඔයාලට තේරෙනවද මම මේ කියන එක? හරි. ලියන්න පොඩි paragraph එකක් මෙහෙම. හරි. පොඩි paragraph normal paragraph එකක් ලියන්න. When we allow alpha, beta and gamma radiations to be flown through alpha, beta and gamma radiations, when we allow alpha, beta and gamma radiations to be flown through an electric field, to be flown through an electric field, to be flown through an electric field, chargeless gamma rays showcases no deviation while positively charged alpha rays deviates towards negative pole. Positively charged alpha rays deviates towards negative pole, and negatively charged beta rays deviates towards positive pole, while negatively charged and negatively charged beta rays deviates towards positively charged pole. Right. පුතා ඔය diagram එක අඳින්න inequality එක d beta greater than d alpha කියලා දාලා ඔය diagram එක අඳින්නකෝ alpha beta gamma d alpha d beta inequality එක ඒ ටික ඔක්කොම ටික මාක් කරලා මේක අඳින්නකෝ. This is my radioactive element. මේක label කරන්න radioactive element එක කියලා. This is my radioactive element. radioactive element, plus and minus charge plates, d beta, d alpha, alpha, beta, gamma, and inequality must also be written, d beta is greater than d alpha. D beta is greater than d alpha. Lamai, please convey the message among all your friends. Please do it for me. Physically, එන්න පුළුවන් හැමෝටමත් දැන් මේ month එක අදින් ඉවරයි. Next month එකේ ඉඳන් එන්න කියන message එක convey කරන්න. This is a golden opportunity for them. සමහර ලාවට they might get influenced by several other lecturers. මේක එන්න එපා යන්න එපා වගේ නිකන් negative impressions දෙයි because they can't survive when we start like this. Physics අයටත් maths අයටත් ගොඩක් අයට ඒක pressure එක අපෙන් exert වෙනවා. මම කියන්නේ කුරුණෑගල එන අයට. Don't consider their words, they are just nothing, right? They are the people who can't face the main competition and get isolated and do English medium classes. See how many of them have number of students and best results in single medium classes? Or bulk in district එකේ ලොකු results තියන අය නෙමෙයි ඔක්කොම. පොඩි classes කරලා වෙන විදිහක් නැති හින්දා English medium class කරන අය. So don't consider their words, just don't මොකක්ද ඒක කියන්නේ ඔයාලගේ future එක උගස් කරන්න එපා on because of them, because this is your future, your stuff, right? එහෙනම් මේ convey the message, I need your support, please convey the message among everyone. ළමයි හැමෝටම message එක convey කරන්න physically එන්න කියලා කුරුණෑගල වටේ ඉන්න ළමයි ඔක්කොටම. And all island students, I need your support පුතා, please convey the message among everyone. We have about 400-500 students island wide from each part of the country. So please convey the message among everyone. Ask them to join with us. Get the things premium. As the may process එකත් එක්ක involved වෙන්න කියන message එක ඒගොල්ලන්ට දිගට දෙන්න. No one do like this. Again, එච්චර past paper questions මෙහෙම මේ type එකෙන් they are not getting this stuff. හරි. Listen to me. තව එක පැරා එකක් ලියන්න තියෙනවා මේ. It's like this පුතා. Right. You have to justify or explain කරන්න වෙනවා why deviation of beta toward positively charged plate is higher than the deviation of alpha towards negatively charged plate. D beta is higher than D alpha. Why? That has to be explained. Right. Listen to me. Puda, deviation of charged particles in an electric field or magnetic field. මේක ඉලෙක්ට්‍රික් ෆීල්ඩ් එකක් වුණත් එහෙමයි මැග්නටික් ෆීල්ඩ් එකක් වුණත් එහෙමයි. මොකද මැග්නටික් ෆීල්ඩ් එකක් කියලා කියන්නේ? මැග්නටික් ෆීල්ඩ් එකක් කියන්නේ කොහොම එකක්ද? Tell me. If we use N and S magnetic poles here, then this area becomes which field? A magnetic field. The magnetic field එකක් හෝ electric field එකක් through charge particle එකක් යනකොට එයාගේ deviation එක depend වෙන්නේ ඒක proportional to, deviation is believed to be proportional to the E upon M ratio value of that particle. ඒ particle එකේ කාටද proportional වෙන්නේ? charge upon mass ratio එක අපි අර ගිය සතිවල calculate කරේ proton එකේ electron එකේ. E upon M ratio එකට proportional ලු. හරි. මෙන්න මේ alpha particle එකක E upon M ratio එකට වඩා beta particle එකක E upon M ratio එක වැඩිලු. ඒ හින්දා positively charged plate එකට beta වල deviation එක negatively charged plate එකට alpha වල deviation එකට වඩා වැඩි කියලා අපි consider කරනවා. හරි? හරි. අපි ඕක ලියමු. ලියන්න paragraph එකක මෙහෙම. para එකක ලියන්න. ලියන්න. රතු පෑනෙන් ලියවට කමන්නේ. You may use your red pen and write. තරුවක් දාලා red pen එකෙන් deviation of a charged particle, deviation of a charged particle, deviation of a charged particle when they flow through an electric or magnetic field, when they flow through an electric or magnetic field, when they flow through an electric or magnetic field, depend on when they flow through an electric or magnetic field depend on the E upon M ratio figure depend on an E upon M ratio figure of that particle. E upon M ratio figure of that particle. Within brackets you may write, higher the E upon M ratio, higher the deviation. Higher the E upon M ratio, higher the deviation. Higher the E upon M ratio, higher the deviation. Higher the E upon M ratio, higher the deviation. You may close your brackets. Since beta particles have got higher E upon M ratio value, since beta particles have got higher E upon M ratio value, since beta particles have got higher E upon M ratio value, higher E upon M ratio value, since beta particles have got higher E upon M ratio value, d beta seems to be higher when compared to d alpha. D beta seems to be higher when compared to d alpha. D beta seems to be higher when compared to d alpha. D beta seems to be higher when compared to d alpha. Within brackets you may write the inequality d beta is greater than d alpha. Inequality එක ලියන්න එතන වරහන් ඇතුලේ. D beta is greater than d alpha. Right, that's it ළමයි. එතකොට ඔය කොළ සෙට් එකේ තියෙන ටිකයි අපි නෝට් එකේ කම්ප්ලීට් කරපු ටිකයි ඔක්කොම පාඩම් කරන්න මම ලොකු සබ් ටොපික් එකක් උගන්වනවා ඊළඟ සතියේ O level කාලේ ඉගෙනගත්ත එකක් isotopes. හරි, ඒකේ mathematical calculations උත් තියෙනවා. log books අරන් එන්න simplify කරන්න ලඝු පොත්. හරි, මේ අපි next week එකේ chapter 2 වල past paper questions ටිකයි workbook එකේ questions ටිකයි ඔක්කොම කරලා chapter 2 එක අපි next Friday වලින්, next Friday කියන්නේ මම හිතන්නේ 3rd of March, 3rd of April, අපි 3rd of April වලින් මේ chapter 2 එකේ වැඩ ටික complete කරමු. හරි. පුතා මේ next month එකේ Fridays 4 එන්නේ 3rd, 10th, 17th, 24th. ඒ දවස් හතරම සාමාන්‍ය විදිහට තියෙනවා. හරි. ඒ කියන්නේ no stopping will be there. The classes will be held as usual. මේ එතකොට every Friday අපි 2:30 to 5:30 කියන පැය තුන එක දිගට වැඩ කරමු. හරි. ඒ පැය තුන මේ වැඩ ටික කරගෙන යමු. right. මේ පුතා මට I need little chat from you guys. Right, how was the day? Was everything clear? Lama, you tell me. I need feedbacks. Was everything clear and was it nice? Super. Okay. Right. For you guys also, was everything clear? Hari, please convey the message. Right, give me that promise. Please convey the message among all your friends. Physically එන ළමයි ටික පුතා ඔයාලා physically යාළුවන්ට එන්න කියන message එක convey කරන්න. මේක තමයි අපේ fixed time slot එක. This won't be changed. මේ 3rd of April, 10th of April, 17th and 24th. ඔය Fridays ටිකේ අපි මේ 2:30 to 5:30 පැය තුනයි අපේ class එක. වැඩ ටික මේ විදිහට කරගෙන යනවා. සමහර විට ඔයාලට සමහර classes පැය 4ක් කරනවා ඇති. but ඒ වගේ interval එකත් එක්ක effective time එක about 3 hours and 25 minutes, 3 hours and 30 minutes like. But we are using our textbooks. එතකොට note එක ලියන්න යන වෙලාව අපේ ගොඩක් save වෙලා තියෙන්නේ. So 3 hours slots would be good enough. If not, I'll be going for extra classes, but 3 hours slots are good enough. Mark my word, I'll be sticking to my plan. අන්තිම මං කියන ඕපදූප ප්‍රමාණයත් අඩුයිනේ. එතකොට with that also I'm concentrating on the subject. These are very familiar for you. Right, okay. Crystal clear, superb. Right, I'm really happy about your feedbacks and the way you guys are interacting with me. So we'll see you on next Friday then. right? Please, live එකේ ඉන්න ළමයි පුතා, or the online guys, please convey the message among all your friends, please. And the physical guys also, use please convey the message, right? Right, okay. පරිස්සමින් යන්න එන කට්ටියම, we'll see you on next Friday. Cheers ළමයි. Right. I won.